This video covers the overhaul of the General Motors 4L60E, probably the most common transmission in the world. Now this is a lab unit. I gotta put a little disclaimer out there at the beginning. Normally when you overhaul a transmission, you're gonna be changing clutches. You're definitely gonna change all the seals in the transmission. You're gonna take the valve body apart, clean it really well, and check all the valves and so forth. In this transmission, you're gonna see I'm gonna skip some of those steps and I'm gonna reuse a lot of different things. So take this video as kind of a guideline of what you can do when you're disassembling this transmission and reassembling it, including some of the different checks, air checks and clearance checks that I have you look at here. In this video, I really don't cover all the updates and changes and improvements that they've made. It's really just to focus you on the operations and procedures following the service manual that you will accomplish in the lab portion of this class. The 4L60E is used in quite a few GM vehicles. This here shows the identification tag that you find on these 4L60Es. That first digit, 9, is the last digit of the year, and KCD is the model number. If the sticker's torn off, there's also etching on the case. Here we could see the same 9 KCD, and there's a 217K as well. The 217 is referencing the Julian date calendar. So this was built on the 217th day. The K is likely a shift or something that has to do with the assembly line. First we need to take this bell housing off. It uses a special Torx socket, a Torx Plus socket. Sometimes these bolts can be difficult to come off, and a technician might use some propane to heat up the aluminum area around it to soften it a little bit. If you end up stripping one out, a lot of techs will use an air hammer or an air chisel to kind of catch the edge of it and break it loose. Here we have the bell housing off and out of the way. It might seem a little out of place, but the very first thing we do is we take the servo assembly out, even with the oil pan on. And the service manual has us do this because they want us to check the pin length before we take it apart. To get that servo assembly out, with a pair of channel locks, you can grab the servo cover and use a pick and get underneath the seal and lift the seal up and kind of stretch it a little bit. When you stretch it, it makes it thinner, and that allows the cover to come off. Hopefully you won't tear the seal in half. Now you can see the servo assembly's out. In order to use the special tool to check the servo pin length, we need to pop the clip off the servo there and actually pull the servo pin out by itself. The special tool will clip into the servo opening using the same servo clip that you pulled out. Hopefully it'll go in a little easier for you than it did for me here. Then you'll insert the servo pin and the sleeve that goes around it. We use an inch-pound torque wrench, and you apply 100 inch-pounds of torque on that servo assembly. And you should see this line, this etched line in that little window there. If you don't see that etched line, the pin's either too long or too short. In this case, we barely saw that line, so we were probably okay. This here shows you the different length pins that you have. The one that we had in this transmission had 2 grooves in it, so that was the medium-sized pin. At this point, we want to go ahead and take our pan bolts off and start disassembling the transmission further. Now we got the pan off, we could see the internals. It's the oil filter, there's just the interference fit there. Disconnect all of our electrical connectors. We have to pull this clip off. This is the torque converter clutch PWM solenoid, and it's kind of trapping the other torque converter clutch solenoid in the bolts. So once we pull those 2 bolts out, we can get that harness out of the way. That's the electronic pressure control solenoid and the little harness that goes with it. Remove all the rest of the valve body bolts There are 3 bolts that are a little bit longer than the rest, and they go in those 3 locations right there. I'm just pointing that out ahead of time. I'll point it out later in the video as well. A lot of people get those bolts in the wrong spot. Once you take the valve body out, you can see that we have some check balls in there. Now, these were glued in there from the previous time this transmission was put together. Normally they're laying on top of that spacer plate. There's a spacer plate, it came off. Take the gasket off. And go ahead and pull our 3/4 accumulator assembly out. Now that we have the valve body off, and more importantly the torque converter clutch solenoid out, we can go ahead and pull the oil pump off. First we want to take that O-ring off. That'll prevent it from sliding, the pump from sliding over the input shaft. Then we remove all the oil pump bolts. If you look at this oil pump, there's a recess for, these bolts have a recess for an O-ring, and the kits that you can rebuild these transmissions with come with replacement O-rings. That little spot right there we could stick a pry bar in, and when we pry up on it we can get that oil pump off. They usually don't come out this easy. Usually you have to hit the side of the input shaft like that and it'll kind of jiggle it out. The reason why this one came out easy is because it was missing that O-ring there, right there. There's a D-ring seal that goes around and prevents the pump from leaking. It seals around the case. Then that gasket right there seals off the hydraulic passages, and that the O-ring seals off between the pump and the case. It's a little plastic thrust washer. You just grab that input shaft and jiggle it around and you can lift the whole input drum assembly out. These are all my input clutches right here. It's a reverse input clutch and then the reverse clutch housing. There's an overrun, forward, and 3/4 clutch assembly in there. Then this is the 2/4 band, applying 2nd, 4th. This thing has a pretty good amount of wear on it. Next step is to remove this snap ring that holds the output shaft on. Definitely wear safety glasses when you do this because that spring could shoot out and get you in the face. Hold the bottom of the output shaft when you pull the snap ring out or else it'll hit the ground. This is part of the input gear set. So that's the input carrier and input internal gear. And this is the reaction sun shell. It's supposed to have a little hub there that drives the sun gear. As you can see, that's broken off. Here's the sun gear with part of the shell still on it. So it's supposed to be together like that. That was the problem with this transmission, the reason why it failed. When that shell breaks, you lose reversed, 2nd, and 4th gear. This is a J28585. I don't like to call it a pry bar or a screwdriver. It's too weak to be a pry bar. It's easy to bend. It's really a snap ring remover tool, but J28585 is easier to say. That helps you get that snap ring out. And then you put the output shaft back in there and tap on the end of the output shaft. This is going to help you get the low roller assembly out with the clutches. You see this is taking a lot of force. Usually it doesn't take that much, so I had to push on this spring that's in there called the K-saver to kind of compress it a little bit, and that helped me lift that out. So that is the whole reaction gear set, the low roller, and that's a low support right there, a low roller clutch. This is the low reverse clutch assembly that we're looking at here. If it ever comes off. This is what we call the reaction carrier, and then the reaction internal gear. Everything on the back half of the gear set is called reaction, and everything on the front half is called input, regardless of what they actually do or what they're connected to. The next step is to remove the low reverse piston, which involves removing the low reverse piston spring first. That right there is a K-saver. That's what I was fighting a little bit, trying to get the low support out. We'll see more about that a little bit later. Here the tool is used to compress the spring, and then I use a couple J28585s to try to get that snap ring off of there. You might be able to get a pair of snap ring pliers in there. Either way, that snap ring is kind of a bear to get off. It's not on there tight, it's just small and there's not much room to work with in there. Once you get it out, you take your tool off and then you can pull the return spring off. I like to hook that snap ring around it like you're seeing here. The reason why is that snap ring is real similar to another snap ring for the reverse clutch housing. That way you don't get them mixed up. Here I'm blowing the piston out, so you can look and see the piston move a little bit when I use compressed air. And it just pushes that piston out, then you can go in and grab it. That piston's got 3 seals to it. That kind of middle seal right there, then there's an outer seal, and then an inner seal. Those seals can get hard, so it's not one of those things that you want to be lazy and leave that piston in the housing. So that check ball right there, sometimes it falls through. It's a capsulated check ball and it might fall through and end up in the case. Now that the wiring harness is out of the way, we can go and inspect the transmission case. One of the areas that we need to check is the third accumulator exhaust check ball. And the service manual will have us take the servo assembly and place it back into the transmission temporarily. And then we're going to fill the third accumulator exhaust check ball area up with kind of an oil, trans fluid and solvent mix. We're going to look to see if it's leaking out of the check ball. Now that leakage right there is actually through an air bleed, and that's okay. But the check ball, the hole where the check ball is, should not be leaking any fluid, and you can see in this case it's not. So now we can trust that that check ball is good. Next step is to reassemble the case. I'm going to start by lining up the lug with the low reverse piston with the lug opening in the case. Place it in there. And since we have new seals, hopefully, on our piston, it's going to take a little bit of force to get that in. Those are square cut seals, so you don't have to really worry about cutting the seal going in, but there's going to be a slight amount of resistance preventing you from pushing that down. So here I just usually use a couple handles, hammer handles, to pop those in there. But I use the tips of 2J28585s to do it. And just like the opposite direction, I'm now going to compress the spring, the piston return spring, so I have room to get that clip back in there. The clip is usually a little easier to get in than it is to get out. I'm still using 2J28585s, reaching down in there and stretching that snap ring around the section in the case that receives it. Then I take the tool off, and now at this point my low reverse piston should be in there. If you remember, I do not want to air check it until I have clutches in there. Next step is to install the Torrington bearing. See, that I purposely did upside down. That is the correct way to position a Torrington bearing. You want to let the inner race, which is the part that wraps up around the inside, like this right here, where the inner race kind of goes up and wraps up around the inside, you want that to be sitting on the gear and wrapping up around the shaft right there where it rides on. It will allow you to put it in upside down, so you got to make sure you know what you're doing. This is the reaction carrier, and we'll want to inspect that before we consider using it. And you can see I'm checking here the looseness of these planetary pinions. There are specifications in the service manual. Also inspect the gears really close. Make sure there's no pitting or scoring. So I found the largest one, the one that had the most slop, and now I'm checking it with the feeler gauge to see how much clearance I have, and I'll compare that to the specs. That one only had about 18 thousandths. This Torrington bearing that you're looking at is kind of idiot proof. They raise the section so it really sits odd if you have it installed upside down. So now I've got this reaction carrier installed. I'm ready to do the low reverse clutch measurement. The service manual has you take the stack of steels that you have, which would be 5 steels, and look for one that might be thinner or thicker than the rest. Typically they're all the same thickness, but if you have one that's thinner or thicker, take it off and place it off to the side. If they're all the same size, just take any old one and put it off to the side. Grab your wave plate with your 4 flat steels, put them on top of your frictions, and put the low support assembly on a flat part of the bench. Then you're going to go around it and measure with your dial caliper the distance from the support to the flat surface. Do it in about 4 or 5 different spots and average your reading. Checking with the service manual, that will inform you on what thickness steel you need. If you need a normal thickness steel, like this one required, or if you needed one that was thinner or thicker. Start building the low reverse clutch pack first by putting the wave plate in. Then you alternate steel friction, all the way till you get up to the top. We need to put this case saver in. The purpose of this case saver is to preload this low support assembly in the counterclockwise direction, and that keeps the lugs in contact with the aluminum lugs, so there's no slapping that goes on, which would prematurely wear those lugs. Here you can see this is the one-way roller clutch. I'm going to check that for operation, but it's always a good idea to take it apart and inspect the races and the rollers. There you can see the rollers with the little accordion springs in there. You want to look close at that inner race to make sure there's no grooves or scoring. You want that to be about as perfectly smooth as you can get it. Now I'm popping out a snap ring so I can actually pull the caged roller out. These things aren't really high failure rate items, but a lot of builders will change these just as part of a normal rebuild. You can almost treat those rollers like a normal bearing, and you want to inspect those little accordion springs in there to make sure they're not broken or falling apart, and also look at the rollers to make sure they're not pitted. If all looks good, spin the rollers back in there and the inner race back in there, and drop this assembly in. You have to index it properly, and you have to also kind of deal with that case saver. It should click into place. And you want the opening of the snap ring to basically straddle that case saver, because that case saver will stick out from the snap ring groove a little bit. You can see there it's straddling part of that case saver, and you could also see how that case saver is pushing the low support assembly. This was the problem with this transmission, if you remember. The reaction sun shell broke, which would leave you with no reverse, no second, or no fourth. So I got a replacement one here. First thing we're going to do is we're going to put a black thrust washer. It's a plastic thrust washer down on that inner one-way roller race. Then we can put our reaction sun gear in and our reaction sun shell. There's a brass thrust washer that fits on top of it. And now we're ready for our input gear set. That's our input internal. Now I'm measuring my input carrier, just like I measured the reaction carrier. I'm going to be checking the pinion gears there to see if there's excessive clearance. Insert the output shaft, and then put your clip, your retaining clip on there. That can sometimes be a bear to do because you don't have much room to work in there, and you have to hold the output shaft with one hand while putting the clip on with the other. The next thing the service manual is going to have us do is overhaul our reverse drum. So that involves taking the clutch assembly apart first. It's a selective plate that we pull off top there, and then we've got our frictions and steels. Reverse doesn't cause too many troubles in these 4L60Es. Then we get down to the very bottom. Right there is a kind of, we can consider that side the virgin side because there's no friction material that runs against it. And then we have this dished plate right there. That kind of works as a cushion spring. I use our foot press here to compress the spring and get that clip off. Make sure you wear safety glasses so you don't get a clip in the eye. Now you want to inspect this drum for where the band rides. It's supposed to be very flat, so you can hold a straight edge up to it. If you see any daylight under there, you've got a warped drum and you need to replace it or refinish it. Like the low reverse snap ring, I try to hook that clip so it doesn't get mixed up. And this is the piston. It has a couple lip seals, an inner and outer lip seal. So the lip seal obviously faces towards the inside of the drum, so that way it can capture the oil pressure, trap it in there. And normally, as you would expect, when we overhaul a transmission, we replace all these seals. Of course, being a lab unit, I'm not as concerned with that. This is a transparency method for installing the piston. The lip seals will give you a little bit of trouble trying to get it into the drum, so you need to have something to help guide that in. And they actually do make a seal installer for this, but earlier on they didn't have that available, so most people figured out a way to do it. You can see we're just using old transparencies to kind of create a thin membrane that allowed the seals to kind of glide in there. And the process works pretty good, and it ensures that you won't cut the seal going in. The trickiest part is not getting the transparency stuck in there. If you push down too hard, the transparency will curl underneath it and it'll be hard to get it out. So here you see I pull the inner transparency out first, and while keeping a little bit of pressure down, I pull the outer transparencies out. You can also use a feeler gauge, and that's very common. You do something similar. Now here's you got a greater chance of accidentally cutting a seal. What you're trying to do is you're trying to push the seal down. Whatever's catching on the edge, use the feeler gauge to kind of push it down. I don't really recommend using the feeler gauge. This is a plastic disc that they provide in some kits. It's like the transparency, but since it's cut in a circle, you can roll it around while pushing down on the piston. And this system works really well. There's probably no chance of cutting the seal with this either. It's a little bit quicker and a little less messy than the transparency, and there's less chance of cutting a seal like you would with a feeler gauge. Not all pistons can you use these because there's got to be a clearance between the piston and the drum. If you have a molded piston, meaning it's got the seal connected to it, there's less chance that you can use these methods. Did you notice how that piston rotated? That's a good sign that there's no flipped lip seal or any issues that you have. Now we're back at the foot press assembling our piston return spring snap ring. And at this point we can build the clutches back up into the drum. Our dish plate with the dish facing down. Try to use the steel plate for reusing your steel plates. Put the virgin side back towards the dish plate, and then alternate your steels friction until we get to the top. Put our snap ring in to hold everything in place. Now we need to do a measurement using a dial indicator to see what our clutch pack clearance is. You could use a feeler gauge, but the dial indicator I think is a little simpler and probably more accurate as far as the results are concerned. So you lift up on it, you push down a little bit. You can see we're switching about between 40 and maybe 95, which comes out to be about 55 thousandths of an inch of clutch pack clearance, which you can see looking at the service information is well within the spec, between 40 and 76 thousandths. Before we call it done as far as the reverse drum is concerned, we want to take a look at the bushing. And I like to place the drum on the part that it rides, and in this case it's the oil pump. And then you move it back and forth and you try to take a look at the slop that you might have. And you can see this bushing is actually pretty worn out. There's a little bit of slop in there. You can also visually inspect these bushings to see if there's any scratches or gouges in them. Now we're going to move to the input drum overhaul. First we got to pull this heavy snap ring out using a J28585. Then we remove the clutch backing plate. These are boost springs. They help keep the backing plate and the apply plate separated when the clutch is not applied. And then these are the 3/4 clutch discs and steels. Take a look at the inner teeth on these friction discs. Those are worn almost completely out. And there's the apply plate. Now this is the forward snap ring that holds the forward backing plate down. We pull these clutches, the forward clutches out. As soon as you put this transmission in drive, the forward clutches are applied. So Torrington bearing, a little separator plate, and then these last two discs are the overrun clutches. The overrun clutch prevents that sprag from freewheeling when you're in a manual gear range. Now I'm using my foot press. I have to remove the snap ring so I can take the pistons out of the input drum. Definitely wear your safety glasses here. That snap ring likes to pop out at you. Take the drum, slam it onto the tabletop, and all your pistons are located in there. There's a 3/4 apply piston, the apply fingers that apply the apply plate, the 3/4 apply plate, the return spring. This is your forward clutch housing. The top piston there is the overrun piston, and the one beneath it there is the forward piston. So there's a lot going on this input drum. Check these little check balls in the forward clutch housing and in the overrun piston, especially if you're going to reuse them. Those little check balls allow the fluid to escape when the clutches are not applied. Now we're ready to go back together with it. We'll first put this O-ring in the housing. It's an easy to forget O-ring. It kind of hides in there a little bit. So if you take one out, make sure you put one back in. And then I install my 3/4 piston. That should be able to be installed by hand. I take my forward clutch housing and I use my fingernail to allow the forward clutch piston to drop into the housing. And then I lay that assembly on the 3/4 apply fingers with the return spring in there. Put a seal protector on there. This protects the inner seal on that forward piston. And then I push out of my grip. I push that whole assembly out. I actually pinch it between the input drum and the one apply finger, and with the other hand I push it out of my grip. When it's all the way down in there, you should be able to feel the springiness when you push down on it. Now this small seal installer is going to protect the overrun piston when I install it. If you don't use those seal protectors, there's a good chance that you'll cut that inner seal. You can get that in by hand just by spinning it and wiggling it around. And when you're done, you remove your seal installer, and it's ready. And now you're ready to go back to the foot press to install your snap ring. Now we're ready to build the clutches up. First, before we jump into that, let's inspect the sun gear. You can see this sun gear actually has some pitting on it. In a live job, we probably would not want to use the sun gear over. This transmission had a lot of miles on it. It had 330,000 miles. We also want to inspect our sprag assembly. So there's the overrun hub, and we can spin off our forward hub, which is also the outer race of the sprag. And you want to look for any kind of grooves or gouges, scoring. You want it to be as smooth as possible. The inner race and the outer race. You don't want it to be able to catch a fingernail or have a lip or a ledge at all. And you look for flat spots on the sprag assembly to see if the sprag is starting to wear into flat spots. A lot of builders will change the sprag just as a matter of habit. This one actually looked pretty good for something that had so many miles on it, and since it's just a lab unit, we'll go ahead and put it back together. When you assemble the sprag, put the sprag on the inner race and kind of spin the outer race to get it on. You could see it freewheels in the counterclockwise direction and drives in the clockwise direction. Sprags are a high failure rate item on 4L60Es. So we can start by installing our overrun steel plate, virgin side down, then a friction disc, another overrun steel plate, then a friction disc. Then that's a separator plate that separates the forward clutches from the overrun clutches. So when you lay that plate down, right now the overrun clutches are below that and they won't apply unless an overrun piston applies. That first plate right there is a wave plate. And then you install steel. If you're using the steels, once again, put that virgin side back down towards the wave plate. And then install friction, steel, friction. Before you get too carried away, it'd be a good idea to install this lube seal and also to put your sprag assembly in there. So we put that lube seal, and that separates the input drum from the output shaft. That allows lube oil to flow. We got our Torrington bearing, and then I went ahead and put my sprag in. Now I finish off by putting my friction steels all the way to the point where I get the backing plate on there. The reason why it's good to do this with the sprag installed is because it's difficult to spin all that stuff in there afterward. And after you get that backing plate on, you can't put the sprag in there at all. It captures it. Here I'm checking the clutch pack clearance. You can see I'm getting about 45 thousandths of clutch clearance. And that's well within the spec, which is between 30 and 69 thousandths. We continue to build this input drum up by installing the 3/4 clutches. You can see I'm reusing these old 3/4 clutches that are bad. These are just a lab unit, so it really doesn't make a difference. These boost springs right here, you want the flat surface aiming down towards the apply plate, and then the part where the springs are sticking up go to the backing plate. The boost springs keep the apply plate and the backing plate separated so the clutches don't drag when the clutch is not applied. Now I got to measure the clutch pack clearance. Push down a little bit and then lift up. You can see I'm getting about 60 thousandths of clutch pack clearance for the 3/4 clutch. Once everything's assembled, we want to go through and air check it. Here I'm checking the 3/4 clutch. It's got a good seal. This middle one right here is the forward. That's got a really good seal. Then this one's the overrun, and it will leak unless I put my finger over the forward hole. And that's got a good seal. The input shaft has Teflon seals that separate from the oil pump to the input shaft that allows oil to flow from the oil pump through the input shaft to the clutches. So you can see here that it allows a stationary object like my oil pump to deliver through those holes in the stator support shaft. It allows it to deliver oil to a moving input drum. At times you have to replace these Teflon seals, so you would use a razor blade to cut those off. Here I'm showing you this is just a single seal. There's no cut to it, there's no scarf cut, so you have to use a installer, and this installer will allow the seal to slide down the shaft there and drop right into that groove. Let's put a little bit of oil on the installer and let it slide down. And when you're done, you're going to notice that the seal is really sloppy on there. That would not be good. If you tried to put the pump on, you'd slice it. So they make a sizer, and you kind of wiggle it back and forth until the sizer falls down. Usually I leave that sizer on there for a while, but you could see right, even immediately right after that sizer was pulled off, it already shrunk that seal down quite a bit. So while you're working on something else, you could leave that sizer on there. Now we're going to go to the pump rebuild. The 4L60E uses a vane type pump, and over the years they've gone from a 10 vane to a 13 vane style pump. It's a variable displacement type pump, so it'll actually change its output. So the internals you'll have a pump slide, a pump rotor, a bunch of vanes, and a vane ring. When you take it apart, you want to inspect the actual surface that the vanes and the pump rotor will run up against. Make sure there's no scoring. You can't feel any edges, catch your fingernail on anything. You also want to take a look at those bushings. Check the bushings for scoring. The best way to check these bushings is to put the pump on the input shaft. And like we've checked other bushings, you want to move the pump back and forth and see how much slop you have. This one's actually not too bad, but there's a little bit of looseness to it. This is the pump priming spring that I'm using a screwdriver or a J28 585 to pop out. There's a vane ring. And I'm going to knock out all the pump internals right here. You can buy these vanes individually, but if you reuse them, take a look. You can see where the vane rings created some wear marks. That's where the vane rings were actually contacting. The other side has a wear mark that goes all the way across it, and that's where the vanes were contacting the pump slide. Even on the edges, you could tell where the rotor was driving the vane. If you reuse those, you always want to make sure that those vane rings are kind of matching the same direction that they operated in. Now I pulled the pump slide out, and I've got a couple seals there that kind of seal it off. And I look at my pump, and just like the other side, we want to inspect the surface, see if it's smooth, see if it catches a fingernail. That's a pump pivot pin, and underneath it is a tiny little spring that's real easy to lose. Now I'm looking at my bushing. 4L60Es use a Teflon coated bushing, and this little stamped steel piece that pulls off pretty easy by hand is a seal retainer. You want to use a screwdriver and a hammer and kind of collapse the seal around the pump. You just work your way around it. Eventually the seal pops off. You always want to replace these seals. And there's going to be some residue left over, so some carb cleaner and maybe the edge of a putty knife or a razor blade, you can get that residue off pretty easy. A lot of people, when they put new seals in, they'll put Loctite around the outside because you don't want that seal ever popping out on you. But make sure it's clean and dry, there's no oil on it. The new seal will have its own little coating on it to help it seal better. See, I'm using the arbor press to help push out the Teflon bushing. It has to go out in that direction because there's actually a step in the pump that the bushing sits up against. When I'm going to install the new bushing, you can see I flipped the pump half. You can use a hammer and a driver. The problem is that they tend to get cocked sideways, and the arbor press does a good job of pushing things in squarely. So you'll press this in to the point where it contacts that ledge, won't go any further, and that bushing is going to be in there perfectly fine now. I'm going to put the seal in, and I'm going to lubricate the inside of the seal with some trans gel or some grease. It's a lot easier to do that right now while installing it than it is after the pump is assembled. Like I said earlier, you could put Loctite around the outside and just use that arbor press to push in the seal. Now we've got the bushing and the seal installed. You might consider measuring the depth of the pocket for the pump slide and rotor. Typically, the pump slides and rotors are about 707 thousandths of an inch. You want to make sure that you are deeper than that. In this case, I'm 710 thousandths, so I got a few thousandths of an inch to work with. If that pump pocket wasn't deep enough, the pump slide would get stuck, and I'd have pressure issues. You can see with the pump slide in there, I put that tiny little O-ring that works like a kind of a spring pushing that Teflon seal. And then I drop my pump pivot pin spring in there, and I push my pump pivot pin in there. This is a little trick. You can compress that priming spring with a vise and then slide it out of the vise into the oil pump. That one almost didn't want to go in there. It got kind of cocked sideways, but I was able to muscle it in there. With my pump rotor, there's this plastic guide that kind of keeps the rotor centered. You put the vane ring in, then the pump rotor with the plastic guide. Now once again, I'm going to be looking at those vanes and the wear marks that the vanes have that were created by the vane rings, I want to make sure those are all facing inward. Otherwise, we might induce a noise. They might create a noise that this pump didn't have before. So if you're reusing vane rings and vanes themselves, you want to make sure that they are going back together the same way that they were when you took it apart. At this point, we've got the pump together, the vanes together, and we got to assemble the two pump halves. Put these bolts in finger tight to begin with. You don't want to tighten these up yet, because those two pump halves are the same size, but there's slop in those bolts. So we actually will use a band to align it. You can see how much movement there is when I just keep the bolts finger loose and move the pump side to side. Now I put the alignment band around it and tighten it up. I'll snug up all these bolts. And I'll torque them to their spec. And put my little plastic thrust washer in, and now my pump is ready to go. I'm going to go ahead and slide the pump onto the reverse clutch housing and the input drum so I can actually air test this whole clutch assembly through the oil pump. And by doing this, I can ensure that I got a good seal all the way through. You can actually see the 3/4 apply fingers move in that picture. Now we're ready to go back in with the input drum assembly. So basically you want to take this whole input drum assembly with the reverse clutch housing on it, twist it and jiggle it inside, get those clutch discs to line up, and when you have it all the way down in there, you'll see you'll have about a little less than a 1/4 inch of movement of the input shaft. But when I put my band in, it's going to be a tight fit, but I can use a screwdriver and I can jiggle that band around and get it in there. Put my anchor pin in there because the anchor pin locks into one side of the band. Then be careful when I move it around because you don't want the band to come out of the anchor pin. Lubricating my O-ring. That was the O-ring that was missing when I took it apart. Put my gasket there. That's a ripped gasket, but it'll work for our lab unit. Drop the pump in and putting these bolts in there so that way I line up the bolt holes. And I tap that pump assembly down. I'm going to tighten just 2 bolts of it because I want to be able to do an input shaft measurement, and if it's off, then I don't have to take everything back apart or take all the bolts loose. All I'd have to do is take the 2 that I tightened all the way down. Here you can see the input shaft end play was about 15 thousandths of an inch, which is well within specification. Spec is between 5 and 36 thousandths of an inch. So I go ahead and tighten the rest of those bolts down and go ahead and torque them. When we get to the point where we're checking the valve body and we want to maybe take some valves out, I usually take them out one at a time. And you can start by popping these clips out and then pulling the end plugs if they have them. Sometimes that's a bear in itself. And we have these organizing trays that will help you keep things straight. So I purposefully like to check one valve bore at a time. So you're supposed to go in, take the valve out, clean it spray it down with brake clean, and reassemble it, and then check these bores for wear and looseness. And the way we're going to go through and check these valve body bores is using a vacuum pump. These charts show where you can check these valve body passages, and if they're screwed up, they have some fixes for them. So first, what we do is we take our vacuum pump. This is just an old AC vacuum pump. I got a vacuum gauge on there, and there's two valves. One valve is I'm going to use to adjust the vacuum, the maximum vacuum, to 25 inches. The other one I'm going to put in this orifice. It's a 40 thousandths hole. I know you can't see that in there, but there's a 40 thousandths hole in there. And then when I put it in, I'll adjust this valve to the point where I get 5 inches of vacuum. So 5 inches, so whenever I'm checking these, if I see 5 inches of vacuum, that would be the equivalent of a 40 thousandths hole. And if I had a perfect seal, that would be the equivalent of 25 thousandths. So right now, you can see I'm already calibrated at 5. Put my finger over it. It's at 25. If I have to adjust these, I can turn the dials. It's always good to check it while you're testing it, because the pump might change its efficiency. But these are also, I don't know how finicky it is. So now that's pretty close. Take my little test orifice out. Now I can go through and test some of these valves. As you might be able to figure out, the vacuum test will actually see how much vacuum it can pull in these little valve passages. You might imagine that if you've got excessive clearance between the valve and the bore, it wouldn't be able to hold as much vacuum because it would leak through. And if you had a good seal, where there's not much clearance between the valve and the valve bore, it'd be able to hold more vacuum in it. So we're going to go through and check all these different passages that are identified on that sheet, and it could be an end plug or it could be a valve bore that's worn out to cause a low reading. Usually 15 inches is about the cutoff, and that just so happens to be between the red and the green areas of that vacuum gauge. If you found a valve that was worn out excessively and didn't hold much vacuum, you can use these boring tools where you go in with the reamer, take some of the aluminum out, and you get a replacement valve and a little bushing that the valve rides in. So you basically replace the casting with a little better quality aluminum, and you will get a lot of your performance back in that valve. We're back at the transmission case and putting the accumulators in. This is the 3/4 accumulator. Push that in there and put the 3/4 accumulator spring on top. The 1/2 accumulator has the springs go in first, then the accumulator piston. That's on 94 and newer units. Then a check ball falls. That's the only check ball in the case that we put that's loose. This valve body gasket right here has a V cut out on it that indicates that it goes on the valve body side. And the gasket on the other side has a C cut out on it that indicates it goes on the case side. Line these gaskets up as well as you can. The first 2 bolts that you put in should be in these locations. That's going to help center the gasket, because the gasket and the spacer plate cutout is actually smaller or tighter in those 2 positions. I go ahead and scatter valve body bolts out throughout the plate. And then what you do is you put this rear reinforcing plate on, and you put the 1/2 accumulator on, and you tighten those up, torque them down, and that'll hold the plate and the gaskets in the proper position. If you don't do this, there's a possibility that the gaskets might shift and they could cover a small orifice or bleed hole. There's a little extra step because you have to remove all the bolts again, but it really doesn't take that much time. Remember to click this harness in. If you forget to do that and you assemble the valve body with the pressure control solenoid, there won't be room to click that in. Then you have to take the accumulator and the solenoid back off. I'm putting the 7 check balls in to the valve body right now, and once they're in place, I'll use Transgel to hold them in place so they don't fall out. Don't lay the check balls on the spacer plate and then try to drop the valve body over it. There's a good chance one will roll out of position and then get jammed in one of those worm tracks. This is the parking pawl bracket. You want to put that on ahead of time too, because if you put the valve body on, you can't gain access to those bolts. This is a big thing here. That link that I just popped in to the manual valve, a lot of students forget to put that in. With that valve body bolted down, you can't get that link in, so you'll have to take the valve body back off. Keep in mind there are a few different length valve body bolts. One of the ones you need to pay close attention to are the ones with 8mm heads. There are 3 of those, and they only go in these spots right here. If you put them in the wrong spot, it's possible that the bolt can actually go in far enough to lock up the gear set. With the bolts in their correct position, go ahead and tighten them up and torque them down. When tightening the valve body bolts, I like to spiral from the inside to the outside. That helps prevent warping the valve body. There's no torque sequence listed in the service manual, but this is the best practice. Put the torque converter clutch solenoid in with its 2 bolts. Let me reiterate what happened in this video. Remember, this is a lab unit, it's never going to see the road, so I reused a lot of parts. I reused the gaskets and the seals, reusing all the electronics. In a typical overhaul, you would definitely replace all the seals, you would clean the transmission very well, you would change the frictions, and you might even change some of the steels if they look like they're overheated. You'd also go through and put a new torque converter in this transmission, or a reman torque converter. You would go through the valve body with a fine-tooth comb. You might change some of the electronics like the solenoids. That would be based off of some symptoms and some diagnostics, or just basically the mileage that this vehicle has. So don't take this video as a complete this is all you have to do to overhaul a transmission. This is really, the point of this was to point out some of the features, measurements, and the processes involved in disassembling and reassembling a transmission. Another thing worth mentioning is that this video followed the service manual step by step. That's not really how things would happen in the real world. In the real world, people would disassemble a transmission, clean it up very well, inspect all the parts, create a parts list, and order those parts. So that way they can rebuild what they need and put it in. They wouldn't be putting things in an order and then inspecting them as they go in. You'd inspect things all at once so you can create a parts list. Kind of going along with that, you can see here I'm going through the final steps of assembly, and I still haven't put the servo in because that's one of the last things that they'll have us do. Right now I'm putting the torque converter clutch O-ring down in there. That's easy to forget. If you forgot that, then the transmission wouldn't have lockup. That would be bad. The service manual has you put this torque converter clutch housing on much earlier in the process. I leave it off on purpose just so it's easier to work around the transmission. The seal retainer helps the seal from blowing out if pressure builds up behind it. The very last thing we do is install our servo assembly, which does seem kind of out of order. If our servo is still disassembled, we'll put the servo pin through the second piston, put the spring on, the washer, and then the clip. Then we place the divider around it. Notice how it's positioned. And then we place the 4th piston on there. This is the 4th piston. Notice how it's positioned. If you have it on backwards, this will actually apply the band when it's not supposed to be applied. It'll drag it on and that'll cause a problem. Then we put on our servo cover with our O-ring seal, push this whole assembly in there. If you remember when we first disassembled the transmission, we used a special tool to determine if the pin length was okay. So the service manual will have us do that again. Of course, we know what we didn't change any parts that were related to this, so the measurement would still be the same. What I'm going to show you here is a better way of doing it, because more likely a shop would not have those special tools. If you take a look, after you assemble the servo and you have the clip in there, look at how much movement we have on this cover when prying out with a pry bar. You should see between a 1/16 and an 1/8 of an inch of movement. If you have less than that, the pin's too long, and if you have more movement than that, the pin's too short. Now the transmission is complete. Hopefully this video helped you understand how to overhaul and disassemble, reassemble a 4L60E transmission. Thank you for watching, and see you on the next one.